Hello everyone and welcome to week 4. This week you'll be making a Popsicle flashlight, but first our interns Quentin and Vaughn are going to tell you some things about electricity.
Welcome back to another Lab in a Bag. Today we'll be talking about electricity. We use electricity everywhere. We use it to power whole cities, our homes, and even some cars. Without it, life would look very different today. There would be a lot of darkness and silence. Thank goodness we have electricity to power so many things in our lives. Imagine flipping a light switch. The lights turn on instantly, right? What allows those lights to turn on is the copper wires that run through your wall and connect the switch to your light bulb. They're very similar to the ones that you got in your lab. The electricity moves so quickly through those wires that it could get to the moon in less than a second and a half. It took the astronauts 3 days to make it to the moon. That's how fast electricity can move.
We learned about potential and kinetic energy when we made our boats and catapults. This week we're going to focus on electrical energy. But first, some quick vocabulary to help you out. Electrical energy is the flow of tiny particles called electrons and protons. Electricity flows one way, from negative to positive. You can think of energy just like water. Water flows from high to low, and just like Quentin said, it only flows one way, just like this waterfall. A circuit is a closed path of electricity that flows from negative to positive. It's kind of like a lazy river. The water goes around in a loop, or you can think of it like a racing track. A circuit can include a power source like a battery, something like a light or motor, and something that can connect it all to make a closed loop. A battery is what we call chemical energy that has been converted into electricity, and this is used as a source of electrical energy for many of our things. You can think of a battery as potential or stored energy. It's stored until the energy is converted to make something happen. So for example, you can think of a lake that is high up on a mountain. It has the great potential to flow down and flood the villages below, but it's currently contained by dams. An electrical conductor is a type of material that allows electricity to flow. You can think of conductors like a river that is connected to the lake. Rivers allow water to flow. Electrical conductors like copper and other metals allow electricity to flow. An LED stands for light emitting diode. So this is a light source that glows when electricity flows through it. The long leg is the positive leg and the short one is negative. And finally, a switch. A switch is something that controls the flow of electricity and can turn it off and on. So you can think of a dam on a river or a lake. The dam controls the flow of the water downstream. We connect it to the Lorax. The child would like to find the once-ler, but it's dark. Help the child navigate their way through the long grickle grass and create a light for them to use. It's time to grab your lab in a bag, grab a friend, and let's get started. Gather all your materials. You'll need 1 jumbo popsicle stick, 1 binder clip, 1 coin cell battery, 1 LED light, copper tape, scissors, tape, and a ruler. Step 1. Trim the end off the jumbo popsicle stick so it has a flat edge instead of a rounded edge. You can cut off around 1 inch. Please be very careful with the battery. Make sure that no one swallows or eats it. This is an additional step that I recommend. You can write down on one side the word positive and on the other word negative. This will help you determine which side you'll put your LED on. Test the battery and LED. Slide the LED on the edge of the battery with the long leg on the positive side of the battery, which you'll see on as a plus sign, and put the short LED leg on the negative side of the battery. If it lights up, you are all good to go. If it doesn't, there might be an issue with either the LED or the battery, so please feel free to reach out to us to ask for more supplies. Next, you'll slide the LED on the curved end of the popsicle stick and lay on the flat surface. The short end of the LED, or the negative end, should be facing up. Now take a piece of copper tape, approximately 4 inches long, and press it firmly over the wire end of the LED. You can start by peeling off a little bit of the end and pushing it over that wire end, and try to make that copper tape strip as straight as possible. You'll also notice I left a little bit at the end. You can make sure you chop that bit off. Flip over the popsicle stick and attach a piece of copper tape to the positive end of the LED, just like you did before. So make sure that you've got a good connection with the LED and the tape, and that your tape is as straight as possible down that popsicle stick. Lay the negative side of the battery on the negative side of the stick and clamp with a binder clip. Flip over the negative side and flip up the clip. Make sure it connects with the tape. To turn the light on, flip up the clip. When the metal clip hits the copper wire, it will turn on as you're completing the circuit. As you're working through your activity, think about the following questions. Which of your materials conducts electricity? What happens when the binder clip is pointing down or away from the copper wire? Why? What happens when you flip up the binder clip so it touches the copper wire? Why does this happen? You can decorate your flashlight, but make sure you do not cover the bottom where the clip needs to make contact with the copper tape. If your flashlight is not working, that's great. Now we get to troubleshoot, which is my most favorite part. You'll first want to make sure that everything that you have in your circuit is flowing from negative to positive. Here is a map of what your flashlight should look like from the side. Then you'll want to make sure that there are no connections that are broken and everything is secure. If there's a break in your circuit, the electricity cannot flow and you will not have a light. If you have any questions, please let us know. Make sure to log into Edmodo, where you can see additional videos, interact with us, and enter our prize pool. A huge thank you to our sponsors for making this all possible. Barletta Boats, Gasket Tape Inc., the Rex and Alice A. Martin Foundation, Heimco, Welch Packaging, and Beacon Health System.